We'll take a look at a symptom you may come across with a 3PCC phone registered to WebEx calling. The symptom I ran into recently while testing elevated levels of mDNS traffic and also ARP in the data VLAN, so not in the actual VoIP VLAN, the data VLAN, was after a period of time the actual phone went into a state where showing offline on WebEx Control Hub. The phone was still WebEx aware. The phone was still registered, and I can make and receive calls. So from a general usage, it does appear to still function. I did have an occasion during my test period, which was approximately day long, that I had one of the test calls did not work, and there was odd behavior that was noticed by the phone. And I'll show exactly what my setup was that induced this odd behavior of the phone showing offline and also potentially occasionally exhibiting some odd issues. So what I was specific testing was VLAN 100, which is the data VLAN. I was introducing elevated levels of mDNS, both IPv4 and IPv6, and also some elevated levels of ARPs. And I wanted to see how the 3PCC phones would react. So this phone here on the right hand side is a 8851 phone with a BE chem. And this on the left hand side is a 8845 phone, no chem. And both of these phones have configurations on interfaces as you see towards the bottom here. So the access for data VLAN is VLAN 100. So if you were to plug a PC into this phone, as I show right here, it would become part of VLAN 100. And it would be able to do its normal transactions, internet browsing, email, printing, etc., etc. And then we have voice VLAN 200, and that's actually what the phone itself will be part of for the actual VoIP transactions. So to actually generate these elevated levels of mDNS traffic, IPv4, IPv6 ARPs, I ended up using software, a couple different software packages. Packet Sender, this is for Windows 10, Windows 11 that I was using. Colosoft Packet Builder, both of these are fairly easy to use and they give you a fairly decent amount of controls in what you can do. iPerf2, and the reason I use iPerf2 is I needed to be able to generate mDNS or multicast traffic. iPerf3 does not support that. I was running this both on bare metal Linux and Windows boxes, and nping, which is a utility part of nmap. So this was also bare metal Linux. So there's a variety of different computers, approximately 10. So Linux, Win10, Win11, bare metal, and also ESXi server with a few Windows 10 VMs. There is a limitation that I've noticed based upon just behavior during testing for both Windows and also Linux when it comes to generating elevated levels of mDNS and ARPs. So you will be limited in how large amount of traffic you can generate, and it is not that much from a single device. So if you do have access to a Spirent, Ixia, or Xena traffic generator device, that would probably be the preferable method versus using software. In the efforts, you'll be able to generate a lot more traffic if you're looking at what tolerances the devices, in this case the 3PCC phones, support. And just to kind of keep things isolated, the physical connection to the firewall were two different interfaces. So the data VLAN to get internet access has a physical interface, and then a separate physical interface for the VoIP VLAN. Again, keep the data traffic separate as much as possible, since I'll be generating elevated levels of mDNS, IPv4, IPv6, and ARPs. Okay, so if you're running into odd symptoms with the phone, such as offline, or perhaps every so often when using the phone, the user's reporting some odd symptoms, one of the first things you can check is the actual interface on the switch where the phone plugs in. So normally what I've seen is most of the time the interface nowadays, unless there's some type of cabling issue, they'll be really clean. So if we look here, there's 0 drops, meaning we're not overloading the interface, which is good. Also, if we look at runs, giants, throttles, input errors, CRC, overrun, ignored, watchdogs, dribble, condition detection, output errors, all of these things are basically clean. So as far as the interface goes, everything looks A-OK. Also, if we take a look at the load on interface, the load is not actually that high. It's 19 out of 255. So I think this works out to like 7.4% of load. Again, very, very light load for a gigabit interface. We're not talking about levels where we're nearing capacity of the actual interface. Very, very light loads. One of the big tattletale signs is what percentage of the overall packets are going to be multicast and broadcast. And we'll notice the multicast packets are actually exponentially larger than the unicast packets, or frames, if you will, in this case. So this will be one of the tattletale signs, just looking at the ratios. Unicast versus multicast versus broadcast. Unless you have music on hold, generally you'll find unicast will be the majority of packets. Broadcast should be very minimal, and multicast, again, unless you have music on hold, also should be minimal. In this case, we're looking also at the data VLAN. So it is possible on the data VLAN there's other traffic, pro audio, pro video, but generally you would want to prune the traffic using IGMP snooping, assuming it is registered multicast traffic. If it is unregistered multicast traffic, then you need to make other considerations, potentially putting those applications in a different VLAN and then pruning the VLAN, potentially using access control lists, and also using storm control commands, broadcast storm control, multicast storm control. There are some negatives with all of those techniques or limitations, but generally you would want to figure out what is the source, and is it expected behavior for the source to be generating so much multicast traffic and or broadcast traffic. So that would be really the first item of focus, is does it make sense that the source or sources are generating elevated levels of multicast and or broadcast. In this specific example, what I'm focusing on is really elevated levels of mDNS traffic and also broadcast. This is actually a 10-second PCAP I took during the actual troubleshooting, where I was testing the elevated levels of mDNS and also ARPs. So ARPs are actually at the very bottom, so those are somewhat limited, but they're still well above what normally would be expected, and also the mDNS well above what would normally be expected. One of the items you may run into challenges is if you have elevated levels of mDNS traffic or other multicast traffic and or ARPs, depending on how elevated they are, you may run into issues with being able to perform Wireshark captures. If you're finding that the notebook or computer you're using is really having issues, you're trying to stop Wireshark, then you're trying to save the actual file and it's just simply not responding, I would suggest putting a 10-second timer and then just capturing it for 10 seconds and see how high the level is. Most notebooks will be able to do at least 10-second snapshot, and then you can evaluate what the situation is. At least identify what are the sources, and then once you identify the sources, you would want to go take a look at those MAC addresses, what devices and where they're located, and figure out really why are there elevated levels of, in this case, mDNS and or ARPs. And I'm just going to take a step back. I was going to mention when you're doing the show interface command, you would also want to add controller at the very back here. This will give you a lot more additional information, and we want to carefully inspect all of this information to make sure there's nothing else of question that might be going on from an interface cabling type of standpoint. So show int, in this case it's gigabit 0/6 and then controller, and that would give you this additional output. Okay, this is what the actual Wireshark content looks like. This traffic was generated using the 4 different software packages I had mentioned earlier. So you'll notice ARP tends to be a minority of the packets, and a majority are going to be the mDNS packets, as you can kind of see here. And again, this would be really abnormal, because if you look at the timestamp here, we're talking about really going down into the microsecond domain as far as how much mDNS traffic is being sprayed, and this again would not be normal. This would be very odd to see something at such elevated levels. I took a snapshot of what it should look like. In this case, it's a pretty small deployment, 10 computers, 1 printer, and I ran this for a period of, I don't know, maybe roughly 10 minutes or so. And so you'll definitely see the red here is mDNS. You'll see some mDNS traffic. You also see some ARPs. But if you notice, we're talking about, you know, like most of the traffic here probably being a 5 to 10 packets per second every so often. And then when you turn on a printer, you may get a larger spike. But generally speaking, there's not that much traffic. Obviously, as you grow the subnet, there'll be more and more traffic. So these gaps you see that I have here, those will start getting filled out, and you may see some larger spikes. And this is where considerations on how big the subnet is really needs to be looked at. Generally speaking, a /24 for optimal performance is what most folks strive. In larger deployments, that may not be possible. As far as practicality, you may need to do a /23, 512, which translates to like 510 addresses available. The risk is you're putting more and more hosts. Not all the devices may be able to support a large ARP cache, so be aware of that. That is something that generally the data sheets do not mention. So as you're climbing into the 500, 600, 700 devices in a subnet, there is a risk for some devices you may be exceeding the ARP cache capacity. The other thing, also just the noise level that you'll be seeing from an mDNS, ARP, and also potentially other protocols. The noise floor level will start rising, and rising. If anything goes bad, that will get amplified substantially compared to a smaller subnet. So those are some risk benefits. Larger subnet, theoretically easier. Just plug in devices and you really don't have to worry about too much from a VLAN standpoint. The negative part is there is potentially more noise right off the bat, even if everything's working okay. If anything goes south, then potentially the amplification of the consequences like a ARP broadcast storm, mDNS traffic or other traffic generally be much greater compared to a smaller subnet. So just some considerations depending on your deployment, options to consider: how large of a subnet, and can you subdivide it into smaller segments. And then once the elevated levels of mDNS were removed and also ARPs, I did actually reboot the phone. I wasn't sure how long it was going to take for the phone to actually come back online. The other thing also that I noticed was overnight, both phones actually lost registration. So when I actually started testing, this was all the way through Saturday, I did have the one oddity with the one phone call where I tried from one phone to the other. I picked it up on the other phone, so I called from the 8851 with the BE cam to the 8845 phone that you see here. No audio. The 8851, it just dropped, meaning there's no more call on it. The call was in a odd state on the 8845 in a sense. It looked like it picked it up, but I could not actually press on any of the buttons to do anything. The only option I had was to hang up the phone at that moment. I was not prepared to catch. I didn't have my video running as far as my camera, so unfortunately I can't show that. But that was one oddity. The second oddity was I left the elevated levels of mDNS and ARPs running on the data VLAN overnight just to see if anything would develop. And when I woke up in the morning, I noticed both the 8841 and the 8851 phones were no longer registered. There was a kind of like a circle indication that was no longer functional. Pick up the handset, no audio as far as dial tone, etc. So I went ahead, I kind of left it like that. I was going to do some additional errands and then come back a little bit later and then take a look at it, do some captures and see what I can figure out. So I came back probably around 11:30ish, and both phones were registered back, and I can actually make calls, etc., which was interesting. Again, I did not touch anything. However, when I started digging in deeper, that's where I had noticed the 8845 was showing offline in WebEx Control Hub. So again, to remedy the 8845, what I ended up doing was the traffic generator computers I had running with the elevated levels of mDNS and ARPs, I basically shut them down. I let the phone run for about 10 minutes just to see if anything would change. I really did not see any change. The phone was still functional. I can receive calls. So I said, okay, let me go ahead and let me just unplug the phone for a few seconds, plug it in, equivalent to doing a shutdown, no shutdown, and let me see if anything changes. And sure enough, once it booted up, about 30 seconds to a minute, WebEx Control Hub shows it online again. Another technique you can use for testing, and it's really simple, if you're having odd issues with a phone, such as the online status showing offline, or other issues, the firmware's not updating on the phone, you're having issues registering the phone, you're having call quality issues, etc., etc., is go ahead and see if you can take the phone to a different location like your home office over the weekend, or if you have two phones, if you can get a spare phone from your IT department and take the spare phone with you home and then do some testings in the evening or weekend, just see if you see any oddities. And if you don't see any oddities following the phone, and you can take your original phone to your home and then have another replacement phone in the cubicle in your office, just to make sure it's not hardware related. And if you notice the problems magically go away if you take the phone with you, you were having problems home, but yet the problems reappear the new phone that you have in your office, then it's very likely something in the environment is interfering or causing performance issues. And this is really where taking a Wireshark capture on a switchboard where the phone is located, also looking at all of the information, not only the VoIP VLAN, but also what is hitting the phone, bombarding the phone from the data VLAN and any other VLANs that might be considered. Any case, hopefully this video gives you some ideas if you're running into odd issues with your 3PCC phone. Definitely consider some of the items I have highlighted in this video. Hopefully this video helps you. Thank you.